Alright, this video is on similar shapes. Similar meaning the same shape, but not necessarily the same size. Because remember, if they were the same shape and the same size, they would be called something else. What would they be called? Starts with a C. Congruent. Alright, so we're going to be checking to see if we have similar shapes, and when we do that, we need to identify the sides that are corresponding sides. So by that I mean the sides that match up or that would be the same side on the two different shapes. Alright, so here we have two triangles. We have triangle ABC and we have triangle DEF, and we need to identify the corresponding sides. So if I choose side AC, that side would correspond with DF. So we would want to look at 4.25 in relation to 2 1/8. So 2 1/8, well, we don't really like to put fractions within fractions, so we need to change 2 1/8 to at least a decimal so we can compare a decimal. So 2 1/8 comes out to 2.125. So we're sticking with the theme here of ratios that we've been talking about throughout this chapter. And so we're comparing the side lengths of these two triangles by setting up a ratio of the corresponding sides. So I have the ratio of AC to DF. And when I set up this ratio, I have 4.25 over 2.125. And if I do the division, I get 2, the whole number. So we're going to check that ratio between the other pair of corresponding sides that I have measurements for. And that's AB to DE. So if I look at AB to DE, that's 4 over 2, which is much easier to see, equals 2. And because I got 2 and 2, and they're equal, these two triangles are similar. That means the scale factor between these two triangles was 2. What that tells me is that this smaller triangle, DEF, all the side lengths were multiplied by 2 to get the larger triangle. Or we could say that the larger triangle was divided by a factor of 2 to get the smaller triangle. So all we're doing is saying that if two triangles are similar, there was a scale factor used between all of the side lengths to get the other ones. So let's take a look at this example. We have the bases on these two triangles. AC would be similar to AC. So we would set up a ratio of 2 to 1, which would just be 2. So if the ratio between the heights of the two triangles is also 2, these would be similar triangles. So we have the ratio of 4 to 3.25. Well, hopefully we know that if to get a ratio of something equal to 2, this denominator would have to be 2. 4 divided by 2 would give us 2. So 4 divided by 3.25 does not equal 2. So these two triangles are not similar triangles because there's not a scale factor that was used to change the larger one into the smaller one by dividing by a factor, or vice versa. There was not a scale factor that was used to multiply the smaller one to get the larger one. Alright, so in this example, we're going to solve for some missing side lengths. We have missing side lengths of the length x on the smaller trapezoid, and on the larger one we have a missing side length of y. And we're going to set up ratios to solve for the missing side lengths, and we're going to use those ratios to make proportions. So let's set up for the ratio. This side 5 would be corresponding to this side of 2. So we're going to do 5 over 2, and we need another pair of sides. So we have a missing side here of x, and it would correspond to this side of 4. So I'm going to put 4 over x. Notice that 5 and 4 are both on the top of the ratios, and they both come from the same shape that was done on purpose. So in between these ratios, I'm going to put an equal sign, because that's how we solve a proportion. So now I'm going to use the strategy of cross multiplication, which we've been doing to solve proportions with percents. And I'm going to do 2 times 4, which gives me 8, and then 8 divided by 5. So 2 times 4 gave me 8, and then 8 divided by 5 gives me 1.6. So this missing side here of x is 1.6. I'm going to erase my work, and we're going to set up for y. Alright, so now we're ready to go for y, and I'm going to use that same pair of sides, the side that's marked in orange, 5 over 2, and this time we're missing y on the larger trapezoid, and that side y corresponds with 1.2. So that would go on the bottom of the other ratio, and we're going to set them equal to each other. And again, we're going to cross multiply. 5 times 1.2 gives us 6, and then 6 divided by 2 would give us 3. So y equals 3. Notice that the two sides here, x and x, are the same. So this would also be 1.6 because these two sides were both the same, 4 and 4. Let's take a look at another example. So here's another example. Let's look at setting a proportion up. So we have rectangles this time, so we only have one missing side. So we have 2 would correspond to 1, and we would have 7 corresponding to x. So this one's pretty easy. 1 times 7 gives me 7, and 7 divided by 2 gives me 3.5. So the missing side is 3.5. Hopefully you were able to look at the two rectangles and you're able to see that the smaller one is multiplied by a scale factor of 2. Or vice versa, the larger one was divided by 2 to get the smaller one. Take a look at the two toolkit entries on corresponding sides of similar shapes and the next toolkit entry on scale factor.